Standard 6.6. Use the definitions of logs to convert between log and exponential form and also to evaluate logs. So let's look at all the pieces of this standard. Our first set of examples asks us to convert from the log equation to an exponential equation. And what we want to remember is the following rule. If we have some base b raised to a power x, and that's equal to some number y, that can be converted to the following expression in terms of logs. We can rewrite that as log base b of y equals x. The whole purpose of a log is to take this exponent x and to isolate it. So logs are always equal to exponents. Let's take a look at our first example. So we want to convert this to an exponential equation. Logs are equal to exponents. So what's on the other side of the equal sign? That is your exponent. 7 is our base. So we change to 7 squared equals 49. Our second example has no base. Or rather, the base is not written. So if the base is not written, it is implied always to be 10. So this particular example would be 10 to the 4th equals 1,000. Actually, that's not correct. It should be 10,000. That makes it more mathematically correct. All right, our third example, we have what we call a natural log. A natural log is just a log with a base of e. So you can think of ln as the same thing as log base e. And so our base is e, we can rewrite this as e. 4 is our power because that's what's isolated here. E to the 4th equals y. All right, our next set of examples says convert the exponential equation to a log equation. So now we're going the other way. Again, we want to look at our exponents. That's what's being isolated. So in our first example, it's going to be equal to -2. That's our exponent. We write log. 1/8 is our base. That is what has the power on it. Log base 1/8 of 64 equals -2. And in our second example, r is our exponent. That's what's isolated. T is our base. So log base t of 7 equals r. Our last set of examples says let's evaluate each logarithm. Now again, a log is equal to an exponent. So what we are doing in this problem, or each of these problems, is looking for the exponent on the base that gives us that answer, the argument. So we're asking ourselves 3 to what power is 81? And that is 3 to the 4th power. Here we're asking ourselves m to what power equals m? M to the 1st power. Here we have 3 to what power equals 1 over 81. Now we know that 3 to the 4th is 81. But this is the reciprocal of 81. Negative exponents do that reciprocal. They flip what you originally have. So our exponent is -4. 3 to the -4th power is 1 over 81. And then our last example here is 121 to what power equals 11. Now notice that the square root of 121 is equal to 11. And square root, which has an implied 2 and an implied 1, can be written as 1/2 power. And so 1/2 power on 121 gives us 11. This is standard 6.6, converting between logs and exponential form and evaluating logs.